Good day, everyone. So today we're going to talk about factorial operation, everything you need to know about factorial. All right, what is it? Well, it's a compact form that shows the product of all positive consecutive integers in a descending order to 1 from the original value n. Now, I wrote down the notation here. The notation for that is n factorial, and this definition basically is a definition of n factorial, and the way it reads is n factorial. And yes, you see this factorial is not like an exclamation sign, but in mathematics that is actually a notation for factorial. All right, so let me give you an example, very simple. Let's start up with 5 factorial. What does that mean? When you see that, that means you start with 5 and then you multiply this product consecutively with all the numbers in a descending order all the way to 1. And notice that it says positive integers. Okay, so no zeros, no fraction, no negative number. It has to be positive. So the way I write it is n has to be greater than and equal to 1 in the factorial notation. Let me give you another one. What if you have 10 factorial? Notice that if you're going to keep writing this 10 times 9 times 8 times 7 times 6, 4, 3, 2, and 1, that's just tedious, right? In some of the operation mathematics and probability and combinatorics, plus some of the calculus topics, we are using factorial notation because it's just easier. The same as exponent laws. It's a repeated multiplication that we use exponent laws, and also scientific notation. That's another one that we use this compact form to make things more visually more appealing and easier to work with. So notice that this thing is just ugly. I mean, who's going to do this? Now, imagine if this was 100 factorial. Oh, goodness, right? So we don't want to do that. All right. So a couple of conventional things we have to know. One is 0 factorial by convention is 1. We just have to remember that. That's the baseline. Okay. 0 factorial is 1. The same thing as 0 to the 0 was undefined or indeterminate depending on the context. So we just have to remember that. But other than that, this is it. This is the n factorial. Now we can use it in terms of operational value for a number, or we can actually use this to solve equations, factorial equations. So let's go through a few examples and come up with some of the answers and process. Let me rewrite the definition of the factorial. N factorial is you start with n, as n is any number that you start with, and then you have to multiply it by the next number is smaller than n, which is n minus 1. Then you multiply that by another number smaller than n minus 1, and it goes down by 1 unit. It's a descending order. And notice that that can continue all the way to the values where you get the multiplied by 2 multiplied by 1. That is the actual definition, a fancy definition of factorial. But what I did, I actually wrote it in this English form so that you understand what that is. But this is the mathematical definition of it. Okay, let's do a couple of examples. First one, simplify this expression, n plus 2 all factorial divided by n minus 1 all factorial. All right, so we're going to employ the factorial notation. So n plus 2 factorial, I can write it as start with n plus 2, and then I'm going to go down by 1 unit every time. The next one is n plus 1, and I'm going to go down again, n, because n minus plus 1 minus 1 is n, and then one more time, n minus 1 factorial. I'm going to stop there, and there's reason for that, and you can see it right now. Every single thing that you've learned about factors, common factors, GCF, everything that you've learned in algebra, now it applies here. And notice that the common factor at the top and bottom is n minus 1 factorial, and you divide, and that's 1. So the final answer in here will be n plus 2 times n plus 1 times n. I put n in a bracket. I don't need to do that. That is the final answer for example number 1. Now notice that I purposely stopped at n minus 1 factorial and n minus 1 value in the product, and I put a factorial in front of it. I didn't continue breaking it down, and you can do that. At any point you want to stop the descending order product, you have to put a factorial notation in front and you will stop. You don't need to continue. And the reason I did that is because I noticed that there's a common factor in a denominator. So make sure you take advantage of this little trick. Here's another question. So the first thing I need you to pay attention to is that the denominator's got n factorial and n minus 1 as a factor or a term. So when you break down the numerator, be aware, be cognizant of these factors. So the moment you see them, you can stop so that it can divide. So let's go ahead. And so the first thing is n plus 1. We're going to write it the way it is. The next one, you multiply it by n. It goes down by 1 unit. And then notice that there is an n factorial there. So I don't have to continue the way I'm doing it here. But having said that, one more may work or may not work. So I'm going to put in n factorial for now. And then let's see what happens to the next. So n factorial times n minus 1. Okay, now, can we divide anything? Sure we can. N factorial, that divides. And then the top, we get n plus 1. The denominator, we get n minus 1. Now, can we do anything with that? No, we can't. So this is your final answer. All right, let's look at next question. So very simply, we're going to go through and we're going to break down the larger value, which is 6 factorial, which is larger than 2 factorial, and larger than 6 minus 2 factorial. Now notice that 6 minus 2 factorial, we have to do the bracket first. So that is 4. So that would be 4 factorial. So we're going to break down the 6 factorial to 6 times 5 times 4 factorial, and then divided by 2 factorial times 4 factorial. So now we can look at common factors for the first step, and this is 4 factorial divided by 4 factorial, and 2 factorial is 2, by the way, right? So 2 factorial is equal to 2 because that's 2 times 1, which is equal to 2. So in here we just can say 6 divided by 2, that's 3, so that would be 3 times 5, and that would be 15. That's your final answer to simplify this factorial expression. All right, so let's move on to the next one, the last question. Okay, last question. This question is a very interesting question because the way I set it up is that the denominator is a larger value than the numerator in both cases. That means you have to break down the denominator first, and it's an addition. That doesn't really matter, but the first thing that you have to do, leave the top alone. So n plus 1 factorial, let's put them all together. N minus 2 factorial is a fraction. And then the denominator here is n factorial. So I'm going to rewrite this. And then the top will end up being n, that should say negative, n minus 1. You can now break it down more. And we're going to go down to n minus 2 factorial because there is a n minus 2 factorial in the numerator. Okay. So here it is. Notice that n minus 2 factorial and n minus 2 factorial, that's a common factor, the greatest common factor from the top. So let's do n minus 2 factorial. You factor that out, you get n minus 1 plus 1, close the bracket, all over n times n minus 1, n minus 2 factorial. Very good. Now we're going to go ahead and simplify. N plus 1, 2 factorial, that divides. The inside of the top, you get n on top because n minus 1 plus 1, that's just n. And then the denominator, you get n times n minus 1. And then the final answer to that, the n and n divides, your final answer would be 1 over n minus 1. That is your final answer, and I hope you found this useful. Check out the next video because this leads into the fundamental counting principle and permutation. All right, until next time.